So we're gonna complete the rest of the topics. So next next step would be audio manager. To set up an audio manager that controls all game sounds, we'll integrate it into our existing game management system. So this system has different managers, each handling specific game tasks like audio, gameplay, etc. in a modular way. So let's go through the setup. So that's on how audio manager will manage sounds and work with the rest of the game. So first step is creating the audio manager class. So audio manager class is responsible for managing all audio related tasks such as playing sound effects or background music, adjusting volume and muting sounds. So to make it work like other managers, audio managers will follow the structure provided by an interface called iGame Manager. This interface ensures that all game managers have a standard way of starting up and reporting their status. So let's go to the audio manager script. So in the audio manager script, the audio manager implements iGame Manager, uh, which meaning it must include certain properties and methods required by this interface like status and uh, startup method. So this setup keeps audio manager in line with the rest of the game's managers. So status, the manager status property. So the status is a property that shows if the audio manager if the audio manager so status is a property that shows if the audio manager has successfully started. Other parts of the code can use this property to check if the audio manager is fully ready. And we are passing in a network service object here right now. This code has it, but in your textbook will we are that step in that step we are not using it. If it's set up as a placeholder in case we need to add features later that involve online connectivity such as streaming sounds from the internet. And in the startup method is called to initialize the audio manager. Here, it logs that it's starting and sets the status to started, indicating that it's ready to use. So next step would be integrating audio manager with the manager's class. So to ensure audio manager starts up with other managers, we need to modify the main manager's script. So this manager's script controls the startup sequence of all managers in the game. By adding a audio manager here, will we make sure it's included in the centralized setup process. So here, so this line of code makes audio manager accessible throughout the game. And let's go to wake. In the wake we have audio get component. This line links the audio manager component on the game object to this property. And the start sequence, uh, new list, this line adds audio manager to the startup list. And the start coroutine startup message managers starts the sequence to initialize all managers. And what else? So managers dot in the for each loop, managers dot startup calls startup for each manager in the list, passing in the network service. So basically we define a static property called audio. This allows other scripts to access managers. manages that audio directly, providing an easy way to control or interact with the audio manager from anywhere in the game. And in the awake method, we assign the audio manager component to the audio property. Then we add it to the start sequence list, which holds all the managers that need to be initialized at startup. And so the startup managers coroutines goes through each manager in the start sequence and calls their startup method passing in the network service instance. So this setup means that when the game starts the game when the when we start the game, audio manager along with any other managers we add will initialize automatically as a part of this centralized process. So coroutine, by using coroutine we can add additional setup steps if needed in the future, like checking if each manager is fully initialized before letting the game start. So by setting up the audio manager as a part of a central manager system, each manager is responsible for a specific part of the game, and audio manager now handles all things related to audio. And all managers, including the audio managers, start in a standardized way, making the game more organized and efficient. And this framework is easy to expand in future. You can add more features to audio managers like volume controls or music fading without needing to adjust other managers. So this approach gives us a flexible and a powerful foundation for managing audio in the game while keeping everything consistent with the rest of the game's setup. So next is implementing audio control with audio manager. So to make audio management in Unity both flexible and easy to control, we'll use an audio manager script along with a simple UI setup. So this approach gives players control over game sound settings like volume and mute, and keeps audio organized in one place. So let's break it down step by step. So first step is setting up the audio manager, as we did. The audio manager script serves as a central hub for managing audio in the game. It will control things like sound volume, muting, and eventually, if desired, music or other audio features. We start by adding it to the existing manager system where all game controllers are managed. So the audio manager gives us a single place to control and manage all game sounds. So this way we don't have to go directly into Unity's built-in settings each time we need to adjust something. So instead we use audio manager. Audio manager handles it. So audio manager, let's go back. As we discussed, the startup method, this function runs when the game starts. Here it sets the status to started, indicating the audio manager is ready. Uh, and the sound volume, this property controls the overall volume of all game sounds. It uses audio listener dot volume, a Unity feature that globally adjusts sound. Get and set make it easier to read or change the volume from other parts of the game. And sound mute property, this property is for muting the game when audio listener dot pause is true, all game sounds are muted. This lets us mute or unmute audio without changing the individual volumes. uh, Next is, so to make audio manager as a part of the games manager, we I think, yeah, we modify the means manager script. This ensures audio manager starts with the rest of the game. So let's go back to the audio managers. We discussed everything about, but we have, yeah, start sequence. So audio manager is added to a list of managers in the start sequence. This ensures it's initialized alongside other managers like a level or player manager at the start of the game. So again, so next is to give players control over sound settings. We create a UI with two features: volume slider to adjust the volume and a mute button to toggle mute on and or on or off. So for that, the settings pop-up script handles what happens when players adjust audio settings through the AI UI. Uh, it has two main methods: on on sound toggle and on sound value. So on sound toggle, this method mutes or unmutes the game by changing sound mute in the audio manager, and the on sound value float volume, this method adjusts the sound volume according to the slider's current value using the sound volume in the audio manager. And for mute button, link the on link event uh, on link event in the inspector to, so link the on link event in the Unity's inspector to on sound toggle, and also link the on value changed event to on sound value, which this method Unity will pass the slider's current value to this method. So as you move the slider, the volume updates immediately. So again, next, to keep the settings pop up from covering the game play screen, we add a UI controller script to manage when it appears and hides. So the player can toggle the pop-up with M key. Uh, so in here, so this script checks if MK is pressed, then shows or hides the pop-up accordingly. And when the pop-up is visible, the cursor unlocks so players can interact with it. When the pop-up is hidden, the cursor disappears and the player can resume normal gameplay. So So with the audio manager and the settings pop-up scripts, we have a centralized way to control audio settings. So this setup is clean and easy to expand. So the audio manager handles all sound controls and the UI lets players settings without interrupting gameplay. So this approach keeps the game modular and organized, making it easy to add more complex audio features like background music management later on. So this design helps with both player experience and code maintenance. So next is crossfading. So to set up crossfading between music tracks in Unity, we are going to use two audio source components and carefully control how each source fades in and out. So crossfading allows one track to smoothly fade out while the next fades in, creating a seamless transition without abrupt audio cuts. So for that, first step is setting up a dual audio sources. So to achieve crossfading, we need two separate audio source components within the audio manager. So let's name them music one source and music two source. These components are responsible for playing different music tracks. So we'll be introducing some key variables in audio manager script to control the uh, crossfade process. So we introduce active music and inactive music. These variables keeps track of. Okay. So these variables keep track of which audio source is currently playing, which is active, which is ready for next track, which is inactive, and crossfade rate. This controls the speed of the crossfade effect. A higher rate means the fade happens faster, while a lower rate makes it smoother and slower. Crossfading, uh, it's a Boolean flag to prevent other music from starting if a crossfade is already in progress. So, and next we'll be adding properties for music volume and music mute. What is that? Yeah. Uh, so we'll add properties for music volume and music mute to adjust the audio volume and mute status. So these properties will apply uh, will apply changes only if a crossfade isn't happening. So this prevents any interruptions during the crossfade. So for music volume, we adjust the audio of both the audio source components, but only if crossfading is false. Uh, yeah, yeah, music volume and music mute. So, so for music mute, we control the mute status for both sources. Uh, so the actual crossfade effect is managed with a coroutine. So crossfade coroutine, which controls which this coroutine gradually lowers the volume of currently active track while increasing the volume of the next track. So let's break down how the coroutine works. First, we assign the new music track to uh, inactive audio source and sets its volume to 0, so it starts silently. And then over a few frames we gradually decrease the volume of the active track and increase the increase the volume of the inactive track using the crossfade rate. And then once the crossfade is complete, we swap the audio source references, and now faded out source stops playing to save resources, and newly faded in source becomes the active track. uh, So crossfading is equal to true, prevents other music from starting during the crossfade. And what else? Float scale rate. This line scale rate by volume level, and the while loop crossfade is for crossfade over time, and this line reduces active volume, and this line increases the inactive volume. And so basically this one swap the active and inactive sources. And what else? So inactive music dot uh, stops the stop the now inactive source. So to start the crossfade in your game, you can create methods in the audio manager that play specific tracks using the crossfade music coroutine. For example, if you want the transition from intro music to level music, you could call the yeah you could like if you want to transition from intro music to level music, you could call this line, and this will initiate the smooth transition from one track to the next. So by using this approach, we manage audio transitions in a smooth and non-disruptive way. So we avoid a sudden shifts in background music, creating a polished and immersive audio experience. So this setup in Unity is versatile, allowing you to crossfade between any two tracks by simply calling the coroutine with desired clip. So this structure also keeps your code modular and easy to expand with more audio features as needed. So to effectively manage audio in Unity, it's essential to understand how Unity handles sound effects, music, and transitions. So first is the file formats and compression. So start with uncompressed files. When you import sound files into Unity, it's best to use high quality uncompressed files like WAV. These files maintain all audio details, making sound effects and music sound clear. Sound effects are often short, so keeping them uncompressed doesn't significantly affect performance. So for longer audio tracks like music, Unity allows you to compress these files upon import. So this is important because music files are much longer if left uncompressed, so they can take up too much memory. So compressed files are smaller, so they load faster and easier to manage in the game. So another thing is 2D and 3D audio. So 2D audio is a sound that plays uniformly across the game, meaning the volume and the quality don't change no matter where the player is located. It's ideal for background music or UI sounds like button clicks. Since these sounds don't change based on the player's movement, they stay consistent. And 3D audio simulates real world effects like linking the sound to specific locations in the game scene. So this means uh, that as players move closer or further from the sound source, the volume and the direction of the sound change. For example, the sound of the waterfall will get louder as the player approaches it. Unity manages this by linking the audio listener, usually attached to the player's camera, to the audio sources, which is attached to the objects that make sounds. And the other thing is volume control. So using Unity has a global audio listener component that allows us to control the volume of all audio in the game at once. So this is useful for setting up a master volume level that applies to everything, like the mute option in the settings menu. And each sound can be individually controlled using audio source components. So this lets you adjust specific sounds like background music or individual sound effects separately from each other. For example, you might want the background music to play softly while sound effects are more pronounced, creating a balanced audio experience. And fading music in and out for smooth transitions. So fading is a great way to transition between music tracks smoothly instead of stopping one track and starting another suddenly. Fading gradually lowers the volume of one track while increasing the volume of the next. This avoids the jarring effect of abrupt changes in music. In Unity, you can create a coroutine that controls how fast the volume changes, allowing for a controlled fade. So coroutines lets you adjust the volume gradually over several frames, creating a smooth, polished audio transition that enhances immersion. So why these techniques enhance the game? Using these audio management systems techniques helps create a seamless and immersive experience. Sounds become a part of the environment, and transitions feel natural, which helps players feel connected to the game. So by understanding and using Unity's audio tools, we can bring the game's audio to life, making it feel dynamic and engaging for players. So by correctly using audio formats, choosing between 2D and 3D sounds, and controlling volume and adding smooth transitions, you create a complete polished audio experience in Unity. So these techniques not only help manage audio but also enrich the overall quality and the feel of the game. So that's the end of this topic.